Welcome to Biology My Passion. I am Soumya Harikrishna. We are going to start a new chapter in Physics, Class 9, Motion. So what is the meaning of motion? Motion means movement. So objects can be either at rest or in motion. So when we talk about rest in terms of physics, a body is said to be at rest if it is not changing its position with respect to a fixed point called its origin in its surroundings by passage of time. For example, if I am keeping this pen here on my palm and I am the observer, so I can be taken as a point from where I am looking, that is the origin, and this pen is not moving its position with passage of time. For example, now I am looking, it's there. Maybe if I can hold for another 10 minutes the same way, it will be there. Or simply think about you are keeping your bag on the table, school bag on a table, and today you are keeping after coming back from school, and you are not taking it. Okay, so in that case what happens, when you come in the evening you keep it, after 1 hour you walk into the room, you are seeing again it is there, and if you are lying on the bed and see again the table, it is on the table not moving. After 2-3 hours also if you see it's not moving, so its passage of time is happening but still it is not moving with respect to the point from where we are looking. That is called at a rest. So there are many things at rest. So whichever objects which are not moving are all said to be at rest. But where in this case motion means what? If a body is changing its position with respect to a fixed point called origin in its surroundings with passage of time. That means a car is moving. So I am looking at a car, it is starting from there, then it is moving, passing by, going. So if I am the origin with respect to me, before it was to my left side there, now it is passing in front of me and going to another side. Or a bird flying from one end to the other, it is going. So these are all called the movement, or these objects are said to be at motion. But every time we may not be able to see the movement or motion. There are some ways in which, or situations where we measure it using the indirect method. For example, if a wind is moving, air is moving, that's called a wind. Movement of air is called a wind. So how do I know that air is moving? I can feel that, right? So maybe my hair will move, or my sari will be moving, or some papers will be taken, or dry leaves will be taken away. From that I can understand it is moving. The same way I can see the leaves of a tree moving. So they, otherwise if they show the movement of growth, that's very slow and invisible. Whereas if it is through wind, we can see that the leaves are moving. So that is indirect way of telling some movement is happening in the air. But now we have to understand another thing. One thing which I am considering as rest may not be at rest for you. Okay, so it is actually with respect to the origin or the viewer, we said, and it keeps changing for different positions. For example, if you are traveling in a bus, that's a typical example we can think of. You are traveling in a bus and your friend is sitting next to you and you are talking to him or her. So during that time you know that your friend is not moving, he or she is also sitting with you and talking to you, and they are not changing their position inside the bus. Until and unless they get up and walk to the other part of the bus, they are at a rest. But if I am looking at the bus from outside and watching both of you moving in the bus, I will say that you are moving. So for me, you and your friend are at motion, whereas for you, your friend is at rest, for your friend, you are at rest. So we can say that there is no absolute movement or motion or rest. They are actually relative terms. So we can say that motion and rest are relative. Relative means what? In comparison to something else. Now there are different types of movements or motion that we see around. That is, if there is a movement of an object through a straight line, for example a car moving on a straight road, or a train moving through its a straight track, all these straight movements are called rectilinear motion. Whereas some are curved movements. Suppose you are throwing a stone, then it will be flying through the air and landing on some water. So it's a kind of curved movement. So that is called a curvilinear motion. Curved motion is called a curvilinear motion. Then another one is rotatory motion. You must have understood rotation of earth, that is rotatory motion, or anything which is rotating. The blades of a fan, that is also rotatory motion. Then oscillatory motion, the pendulum of a clock, that, or if you are just hanging a stone or a pebble with a string, you can see that it is showing an oscillatory movement. So that is called a oscillatory motion. Then finally vibratory motion is there. So you know, vibration in phone we are all familiar with. Whenever we keep vibratory mode on, when we get a notification, our phone starts vibrating. Or the typical example is the string of musical instruments. When you are using that, the strings will vibrate, which produces a sound. Even in our body, the vibration of our vocal cords are making sound. So that's the vibratory motion. So hope this is clear for you. Rest means an object is not changing its place with respect to a fixed point or origin in its surroundings with the passage of time. But if the object is changing its position with respect to the origin and time, that is called at motion. But these two are relative terms with respect to the origin. Then now we are coming to the two types of physical quantities, scalar quantities and vector quantities. So some values or some physical quantities, when we express, we do not say in which direction it is happening. We are simply telling, okay, I am just saying that, oh, you are running. Okay, I am not telling where you are running, or I am not telling which direction you are running. I am just telling you are running. So there we are not including any direction, but I am telling that you are running at a speed of 10 kilometers per hour. Okay, so there I am adding a magnitude for your speed, or the how fast you are moving, but still I am not telling you in which direction you are moving. Okay, so there we are using only a magnitude of that physical quantity. Then it is called a scalar quantity. So a physical quantity which is expressed completely using only its magnitude, that is called a scalar quantity. For example, length. Suppose I am telling the saree is 5.5 meters long. I am just talking about the length, I am not talking about the direction in which I measured it. Or mass of a body. Or I am telling area. This paper is a A4 size paper, and or I tell the area of the paper in square meters or square centimeters. Or a plot I am telling, okay, this is the square feet of my house. So there I am not telling the direction, only the area I am mentioning without any direction. So that is a scalar quantity. Then speed, I am telling you, you are running at a speed of 10 km per hour. I am not mentioning the direction. So speed is also a scalar quantity. Then temperature, energy, power, all these are scalar quantities because we are not using any direction whenever we are mentioning about that. But when we come to certain other quantities, these physical quantities are expressed in terms of both magnitude and direction. For example, if I am telling you are running 10 km per hour speed to the north, then I am talking about something else called a velocity. That is a vector quantity because I am talking about the direction as well. Or weight I am talking about. I am talking about weight means what? Why an object is experiencing weight? Because of the pull of the earth, that is the gravitational force. So that is also a vector quantity. Then momentum, force, displacement, all these are connected with the their magnitude as well as direction. So these are all vector quantities. So if a physical quantity is expressed only in terms of a magnitude, that is a scalar quantity. If we express them in both terms of magnitude as well as direction, then that is a scalar quantity. Hope you find my videos useful. If so, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.